Good afternoon, guys. I hope you have a very lovely afternoon. I prepared myself a cup of tea here, a cup of Yorkshire tea, and I don't have so very good news to share about my previous exam. So yesterday I had an exam on team project based challenge thing. So that was CE291 exam, and it was all multiple choice, so fair enough. But the problem is that I had a few tricky questions and you could lose 2.5% of your overall mark in the exam, so it wasn't really that good. I think I fucked up some part of the multiple choice question in the end, where we had to answer question 31 through 40. As far as the rest of the MCQs before question 31 and forwards, I think I've done pretty well, except for maybe 2 or 3, like the GDPR. For some reason, I always thought that the GDPR was introduced in May 2016. Apparently, it was ratified in May 2018, I think, and was introduced in the European Parliament or something on April 2016. I was most definitely wrong, so I lost 2.5% from that silly question. Anyway, in 2 days, I think, Friday, got an exam on artificial intelligence. I have a lot of things to revise on and take a lot of time to do that. So I have split the workload of revision into 3 parts. So the first part is going to be today, which is already being done. I'm just taking a break and doing this vlog pretty much. So there's just 2 more units left to be done before I go to work at 5. So it's about 2 p.m. So I've got 3 hours to do the rest of the 2 weeks for the particular units, and then I have to move on to unit 2, do the entire unit 2 tomorrow, and then do partially maybe 1 or 2 weeks from the unit 3, so that I have just maybe 1 week of unit 3 left for the day of the exam. So the exam is going to take place on Friday at 2 p.m. So I come back from work at 1 a.m. So I'm going to go to sleep for like 8 hours till 9, wake up and do 3-hour revision, a total revision, go through the revision slide, and be sure that I know what I have to know in order to get a very good grade. The exam doesn't have any MCQs, so it will be all written answers. The good thing about this exam is that it gives you a bit of room, and flexibility in providing your answers, which is a very good thing. Other than that, I want to do a master's in artificial intelligence, so AI is something I'm very passionate about, and I don't think there's going to be any issues for the particular exam. It's just I work 2 days in a row, back to back, from 5 p.m. until 1 a.m. the morning of the following day, so I don't have a lot of time to do the revision. So far, I have calculated that I will have about 16 hours for the revision. I think 16 hours for a revision are more than enough for this particular module in the way it is structured. So I'm going to get back to studying, and I'll see you guys in a bit. Alright, so I didn't have the chance to make some video footage in the past 2 days because I had a lot of work to do. I pretty much focused on doing my revision. I had to go through 19 slides and learn a lot about artificial intelligence, so I had to do a very thorough revision, and at the same time I had to go to work from 5 p.m. until 1 a.m. of the next day. So I had two days in a row work and studying, so I was absolutely exhausted every time I came back from work. Then I had to wake up at 9 and start doing revision, and I only had that much time to do the revision properly. But now I have an exam in about an hour, and I feel like I'm quite prepared for the exam. I've done quite a bit of revision. Even right now, last minute revision, I've started 2 slides. I understand, I think, about 95% of the concepts. Anyway, I have to go now, so I'm gonna get my bike, get my stuff ready. See you in a bit. Alright, so here is a small behind the scenes update. So I finished the exam at 4, which went great by the way, and came back home at 5, and then I went to do some Uber Eats deliveries, which I made about £38, £3 in tips, so it was quite a good day. So the exam itself was quite good. The only bit I struggled with was question 2B, so when I get back home I'll go through all the questions, might even provide some answers to those. Question 2B was 15% of the overall mark, and I think I made quite a few mistakes over there. I may not even get 5% out of those 15% marks for the particular question. So, but other than that, I got about 70 at least, 70% for the paper, which is pretty much great. Right, I'm back home. I'm inside the living room. Right, so this is the bag, pretty much. This is the Uber Eats bag. So I've done 6 deliveries. In 3 hours, so that's 2 deliveries an hour, and I made £38, £3 in tips, so that was £35 just from doing the deliveries. I'm gonna go upstairs, change clothes, make a cup of tea, and then I'll go through the questions in the exam paper. Alright, so I got my cup of tea, which means it's time to go through the questions and provide some brief answers to the question paper. So the question paper consists of 3 questions. Question 1 is worth 40%. Question 2 and 3 are worth 30% each. Now the question 1 is pretty much a series of questions, 5 questions, right over here. So you got A, B, C, D and E. They are all equal weight, so once you answer all of them you're going to get 40%. And they were so easy that if you answered all of them you have about half, 40% of the exam mark done for you, as long as you know what you have to answer. So question 1, it says, Alan Turing proposed the Turing test 1950, aiming to determine whether the machine can think. Give the definition of stronger AI, artificial intelligence, and then explain whether the Turing test is valid for assessing strong AI. Alright, the difference between weak AI and strong AI is, for weak AI, the definition is that it's machines that act or behave as if they can think, while the strong AI are machines that can actually think. So this is the definition, and then explain whether the Turing test is valid for assessing strong AI. The answer is it is not, because the Turing test is based on behavioral observations. Turing said that artificial intelligence is pretty much machines that act as if they can think, and if you want to assess AIs that are strong, which can actually think, you can't have Turing tests done on them based on the definition of the Turing test. Question 1b, describe 2 major differences between state space search and production rule base. So state space search is a general problem solver, whereas the production rule base or production system is pretty much an expert system where you have the knowledge representation and rule representation in it. So that's one of the major differences. The other major difference is pretty much talking about the structure of both of those approaches. So you mentioned how the state space search structures, which is trees pretty much, and you have the states, which are nodes, and branches, which are actions or transitions, and the result is a sequence of states and actions or transitions, whereas the production rule base consists of 2 parts, the situation, and the other part is pretty much the consequent. So you have the left hand side is always the situation, and the right hand side is always the consequent, and you also have to add a bit more information regarding that and how it works. That's alright, that's another 8% easy marks. Describe machine learning briefly from the perspective of model optimization. Explain respectively what structural learning and parametric learning are. Give an example of structural learning. Alright, so machine learning can be defined as optimizing or updating a model by using learning algorithms and some specific performance measures. Now, structural learning and parametric learning are pretty much structural models and parametric models, so you readapt the definition of machine learning to fit those, and you just give an example of structural learning. That's pretty much it, 8% there. The logical and operator is defined as not A and B, and write down this truth table and devise a single McCullough-Pitts neuron that will compute this logical function. This is very easy to do. Write down the truth table. That's very easy. You have A, B, not A and B. So what you do is put true, false for the B, true, false for the A, and then all you have to do is remember what the true values for the AND operators are and do the opposite of that, pretty much. So if you got A and B, so if it's true and true, which results into true, you take the opposite of it, which is F. So there's the NaN value for not A and B, where A and B are both true. So this is just an example. And for the neural network, it's pretty much just drawing what you have. You need 2 inputs. You need input A, input B, and then you have the threshold inside there. That's about it. Question 1e.
From the perspective of if-then rule firing, discuss the major differences between reactive agent with some assumption architecture and a production system where they are applied for robot navigation. Now we have to know, you have to pretty much define what a reactive agent is. You said intelligent agent. Now intelligent agents are systems that are autonomous and perform tasks autonomously, and you also have to probably define what a production system is and give their key differences and explain how this can be adapted into the robot navigation. Alright, question 2A, not question 2B that was bitching about earlier. Question 2A is using the Monte Carlo tree search. So this is how it looks like. There we go. So you're given the formula of UCB. You have to explain briefly why the UCB criterion can balance exploration and exploitation in the Monte Carlo tree search. Honestly, I've had almost no clue, except for the part where I remembered the parts of the algorithm of the formula is exploitation and exploration. I just pretty much broke it down, explained something about that. Now, we are also given a diagram here with some UCB values, alright? And what we have to do is compute the UCB values for the two terminal nodes, which is 2/3 and 3/3. So we have to choose which one to expand. So if you write down the UCB formula and you apply the numbers correctly, you're gonna get the proper answer, and obviously you're gonna find which one to expand. In this case, you have to expand the node with the value 3/3. So you go down to the parent node, you go down to the leaf node, and what you do is you compare the children of the leaf nodes of the parent above, and you get whichever gives you the largest value, the largest UCB value, you choose that one to expand. Now question 2B. To be honest, I didn't have a lot of time to do the revision, so when I saw this, I knew this sort of question would turn up. I've done a few examples, I didn't properly understand some of them, so I had to prioritize. So I prioritized neurons and some other things. I didn't prioritize mycin, even though I knew it will be there. Question 3A. The following data is used to induce a decision tree that can determine the best crop to grow in a particular field given the values of pH, drainage, and soil. So this is what the table looks like. So we are also given us some extra information. So information gain is used as a criterion to select the best attributes. Assume the information gain from pH has been calculated and is 0. Which of the remaining attributes, drainage or soil, should be in the root node of the induced decision tree? Justify your answer by showing you're working. So pretty much what you have to do is find the information gain for drainage, information gain for soil, and decide which one has the better value. Pretty much that, 12%. That's it. That's the answer to the question. You show your calculations, you provide the answer, that's it, 12%. Alright, finally we got question 3B and question 3C. Question 3B is giving you 3 neurons right over here with specific weights and specific values. So S1 and S2 are given to you. So S1 is equal to 0, S2 is equal to 1. You have the weights in there, so all you have to do is just multiply the value you're given S1 by the weight, and you do that for all the neurons. 3C, choose an appropriate machine learning rule or algorithm for each of the following tasks or problems to be solved through machine learning. To develop a face recognition system given a database containing a large number of pairs of faces and identity. Alright, so this one could be, you could use clustering because those are unclassified objects and you have to make sure the classes are distinct, so you have to get it through clustering the groups of photos pretty much. This is what I think. This is not the only answer you can provide, you can provide other answers as well. So C2, question 3C2. To design a controller for a mobile robot for indoor navigation given a large number of sequences of positions and actions by which the robot moves gradually from initial positions to the goal position and the reward for reaching that position. No, that was reinforcing. You are rewarding. The key word for here, why this is reinforcing, is because you give a reward for reaching the goal position. So in reinforcement learning, this is what you do pretty much. You have a cumulative reward and so on and so forth. Finally, question 3C, to find out the number of distinctive groups of flowers given a dataset containing a large number of feature vectors of various flower samples. So this one could be classification. So the reason why I chose to name this as classification, it's because, well, learning by classification is because you have distinct groups already, first of all. You're also given a data set, which is a training set, and you also have specific features, vectors given already to you. So, right, so that concludes the Artificial Intelligence examination paper for 2019. I fucked up question 2B. I fucked it up. There's no way to do anything about it anymore. So other than that, I'm thirsty, I'm tired because I was working, and finally I'm probably going to watch some movies. So thank you very much for watching this video. If you like the comment, click the like button, subscribe, and I might be start doing some coding videos. Alright, see you later.